Hello and welcome to this video. We are going to take a closer look at the marvelous world of dewormers in horses, the enzymatic product portfolio that we have available. And what are the ups and downs? What do we know? What's the confusion? What might have changed since these products were first registered and launched? So let's get into it. We actually don't have that many different enzymatic classes. But we have a lot of different products with different names, and that can sometimes cause some confusion. But if we just stick to the classes, we can go through them one by one. So let's start out with the benzimidazoles. Benzimidazoles were first introduced in the 1960s, so those are the ones that have been around for the longest. There's been many different members of this class over the years. They all end on azole in some form of fashion, so that's how you can recognize them. In most countries nowadays, we have fenbendazole registered for horses. In North America, we also have oxybendazole. In other countries, there might be other benzimidazoles, but they all share the same mode of action, which is also indicated here in the slide. It binds to these microtubules and prevents them from forming, and that's the whole infrastructure of the cell. So without microtubules, the cells cannot function, cannot exist, cannot transport nutrients in and or out of the cell, so they die. So that's how they work. Now, what's the status of, efficacy against the different products? So if you read the label or the insert in the package, and look at what parasites it says that works against, you'll get these parasites mentioned. So a good, nice, broad spectrum. Now, this only reflects the situation when the product was first launched back in maybe 30, 40 years ago. And so, of course, nothing has just stayed the same. We have development of resistance to several of these parasites to this class. So actually the schedule should look like this now. So whenever you see these tables and you see a strike through, that means that the product is highly unlikely to work. Doesn't mean that it doesn't work at all. It could work in some places, but it is highly unlikely to do so because of general findings across the world. Whenever something is highlighted in red, as you also see here with the asterisks, that's when we have reports of resistance published in the scientific literature, but it doesn't appear to be as widespread yet. So we went from a broad spectrum to a not so broad spectrum. And as you will see in this video, that story is actually exactly the same for all of the drug classes that we have. So it's not just unique to the benzimidazoles. So one thing to consider here with the benzimidazole is that one of the products, fenbendazole, is registered and licensed to kill the encysted small strongyl larvae. Those are the larvae that live in the intestinal wall of the horses, and there can be hundreds of thousands of them. They can cause disease, severe profuse diarrhea, and so we do have special interest in products that can reduce these larval burdens. And the 5-day course of fenbendazole has been registered and tested and demonstrated to do so. So what we're looking at here in this table is you see the dosages up top. They're a little different between Europe and the US, but efficacy levels are actually the same regardless of those two different dosages. And then we look at some historic studies from the 90s. You look at two different larval categories. It doesn't really matter what they are in this context, but just know that there are two different categories of larvae, the EL3s on one hand, and then the LL3s and the mucosal L4s. And so we look at these efficacy levels independently or separately, and what you notice is that back in the 90s we had very good efficacy in all cases above 90% reduction of fenbendazole of the 5-day double dose course. Now, two recent studies that we've been involved with have demonstrated that that doesn't appear to be the picture as much these days. So you can see that the efficacy levels have come down significantly against both of these larval categories. So in these two studies, for sure, we have demonstrated resistance at the larval stages against this treatment regimen. So do we have larvicidal efficacy? Well, yeah, there is a reduction, but it is not as pronounced as it used to be, and it does define the definition of anthelmintic resistance to this product. So that was the benzimidazoles. Now, moving up in our timeline, the next drug class to get introduced was the pyrimidines in the 1970s. In the pyrimidine class, we have products containing pyrantel, different salts of pyrantel. The most well-known product name you see here on the slide, you saw on the previous as well, that I'm mentioning a few product names so you can relate to products that you might know. So pyrantel has a different mode of action. It is actually a paralytic drug. It binds to certain receptors and induces a spastic paralysis. The worm gets like really stiff and paralyzed, and loses its grip or its ability to swim against the bowel movements, and then it gets flushed out and it dies. So looking at the spectrum of pyrantel, it is also quite broad spectrum, and one thing we notice here at the bottom is that it also has activity against tapeworms, which is quite unusual. Now again, this was the world as it looked like in the 1970s when the products were first launched. So how is it looking today? Yes, again, we have some strike through here. On the Starngels, we have some red highlighted areas, ascarids, and notice the tapeworms here. So that's a very new development that in only one study thus far, but one that we just published, we've actually demonstrated evidence of treatment failure of this particular product. Now, also, some of you may be aware that the labeled dose for tapeworms is a double dose. That's been demonstrated to be more effective than the single dose against tapeworms specifically. Doesn't really change anything for any of the other parasites, but against the tapeworms, we got about 10% better efficacy when you double the dose. So you went from about 85% to about 95% efficacy. So at the double dose, we still see evidence of treatment failure in this recent study. Actually, here's a table from that study. And the way to look at that is that we have 4 different groups, A, B, C, and D. We have the pre-treatment counts and the post-treatment counts. And then you have the number of positive horses out of the total number tested, and then the range of counts for each of those 2 rounds of counts. So what you notice if you look across is that nothing really changed from before to 2 weeks after treatment. So that's a clear indication of something ain't right here, right? We're supposed to see these egg counts clear up, and they didn't at all. So that was the pyrimidines. Now to the third class, which is macrocyclic lactones, and in that group is where we have the most widely used drugs, ivermectin and moxidectin on the northern hemisphere. On the southern hemisphere, there's 1 or 2 other members of this class that are also licensed for horses, so there might be other, as they call it down there, mectins, so something that ends on mectin, like abamectin and so on, that also belongs to the same class. However, ivermectin and moxidectin are the most widely used, and again, we see here introduced in the 80s, so that's 40 years ago plus. And this is the newest class, ladies and gentlemen, at least for the nematodes, the roundworms, and it's concerning that we haven't seen anything new since then. And this is also a big problem because, of course, these products, these classes are slowly running out. They're slowly losing efficacy, as you've seen already. And we don't have anything new coming out the pipeline, at least not as far as we know. And that is a concern. So ivermectin, moxidectin, wonderful success story in terms of animal health and protection of animal health in efficacious treatments, but those are now also running out for us. So looking at the spectrum, originally they were very broad spectrum, and one thing we notice here at the bottom is that we for the first time see the bots. Bots are insect larvae, so they're not really worms. They belong to an entirely different family, yet ivermectin and moxidectin, especially ivermectin, not so much moxidectin, but ivermectin particularly, has efficacy against these bots, against the larvae in the stomach, and sometimes also in the oral cavity. However, how does that look today? And again, we see here clear evidence of resistance widespread in both ascarids and now also pinworms, which is something that doesn't really cause a lot of disease, but does cause a lot of tail robbing. So horses that rub their butts, and they can keep doing so in a frantic manner and cause a lot of damage to themselves. So pinworms is becoming a problem, and now we see in red also strongyles. We do have reports showing strongyle resistance, and so that's really a concern here, especially because we're running out, as I said. And now, going back to the topic of so-called larvicidal treatment, so products that work against these encysted larvae of the small strongyles, those that live in the mucosal walls of the large intestine, moxidectin also is a larvicidal product. However, let's take a look at the data. So similarly to the benzimidazole, the fenbendazole data I showed you before, we also here have some historic reports and then some more recent reports. And one thing you notice here is that it never really wasn't that great. I think moxidectin sometimes gets a bad rap for being so highly effective that it might be dangerous to the horse to kill so many parasites at once. Now, well, it clearly doesn't kill all the parasites, and it never really has. So this doesn't demonstrate any development of resistance. It just sort of says, well, you're not going to wipe out all the larvae. There will always be large proportions of these encysted larvae that do survive the treatment, and in some cases, if horses have hundreds of thousands of these larvae, well, they may still have hundreds of thousands of these larvae following the treatment. So this is just something to know that it does have activity, however, not anywhere near 100%, and it never really was. In some cases, it was actually quite low, and it's variable between studies, as you can see. It now actually kind of looks like it's at the same level of efficacy as we see with the 5-day double dose of fenbendazole that I showed you before. So that's kind of interesting. So we have two larvicidal products. Neither work particularly well, but both appear to still have some activity against these encysted larvae. Is it enough to provide a clinical relief? We don't know. Is it enough to prevent against any disease of happening in the near or distant future? We definitely don't have any data to support that either, so we really don't know how much it helps to deworm with a larvicidal product, and this is an area where we need more research. So that was the macrocyclic lactone. So now we've talked about 3 different classes, but there is actually a 4th anthelmintic class that is labeled and registered for use in horses, and that is the quinolone pyrazines, or praziquantel. Praziquantel, you probably know. It is in several different combination products. It's also used against tapeworms in small animals, so you may know about it in dogs and cats. But it is also available in several different combination products in horses. So usually it is combined with a macrocyclic lactone, either moxidectin or ivermectin. On the southern hemisphere, you might see a few additional possible combinations there, but for the most part, it is combined with a macrocyclic lactone. It works, has a very different mode of action. It sort of interferes with the cuticle, the skin of the worm and increases permeability, and then it dies because it loses salts and nutrients, etc. In that regard. It is just as effective, or was at least, as the double dose pyrantel we talked about before, around 95% reduction of tapeworms. However, we have seen, that this is the label claim, one group parasite it works against, and now notice that it has turned red. So similar to what we just demonstrated for parental pamoate, the double dose of that against tapeworms, that we've seen one report of treatment failure. We have actually, in that same study, we also saw treatment failure of paracetamol. In fact, in one particular study we did, it was two different formulations, two different products, and neither of them worked. And so we look at this table here. It is organized in the same manner. You have the 4 different groups, the pre-treatment counts, the post-treatment counts. First column is the number of positive animals out of the total number of animals, and second one is the range of positive counts in the positive animals. And if you look across, you can just say the same. There really wasn't any change from the day of treatment and then the post-treatment counts that were determined 2 weeks post-treatment. So clear evidence of treatment failure, and this is something that we should all look out for. So this is really it. So these are the 4 classes. I think in summary, we should just all keep in mind that they still work. Each of them still have activity against some parasites, but we no longer have this good all-round dewormer that takes, quote-unquote, takes everything, as people often ask for. That doesn't exist. And as veterinarians in this field, we really need to provide the right advice and guidance, and there's just no way around proper testing. We need to know what parasites we're looking at, tapeworms, ascarids, Starngiles. What are we finding? And also, what's the efficacy that we observe? So remember those post-treatment egg counts. Those are sometimes even more important than the pre-treatment counts. So some testing is required. And that's it. I hope you found this useful, and stay tuned for another video on how to choose the right dewormer. Thank you.